All right, so we're moving on in our radicals unit. Last topic we're doing is called solving radical equations graphically. Okay, so all right, here we go. So for the first example over here, it says solve the equation graphically and algebraically. So we're going to solve this one graphically first. I'm just going to use my calculator for this one. So to solve this one graphically, okay, we're just going to go onto our TI-84 plus calculator. Y equals, clear out whatever you have in here, and we want to go to the square root of 2x plus 3, y2 equals x. So when we press graph, we're looking at this, we see this graph over here, and we're looking at this intersection point here. So we want to go second calc, intersect, enter, 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 and we get 3, 3. So thing to remember, when we're solving anything graphically, the solution is going to be this part, which is the x value of the intersection point. This part, y equals 3, is not going to be a part of your solution over here. Okay, so so the solution is going to be x equals 3. So back to our over here, we have, we're seeing a graph that looks like this, and we have this intersection point here, and oops, where'd that graph go? And guys, this picture is brutal, but the intersection point was at 3, 3. Okay, so our solution would be x equals 3. All right, here's how we solve this one algebraically. Now, really, guys, sorry, guys, just pardon this drawing over here. This intersection point was drawn very poorly. It should have been intersecting right here and here for these two graphs, but my graph was actually really poorly drawn over here. In Math 20, we spent a lot of time solving these ones algebraically. Okay, so just going to kind of quickly review how to do these ones over here. And really, guys, the focus for Math 30 is going to be solving these guys graphically as opposed to algebraically. So, in my opinion, I think the Math 20 curriculum for this topic was actually was a bit harder than the Math 30 stuff is. So, solving this one algebraically, we're going to go square root of 2x plus 3 equals x. And then we're going to square both sides. And that means we get 0 equals x squared minus 2x minus 3. So 0 equals, I'm going to solve this one by factoring. This guy factors really nicely for us. X minus 3, x plus 1. And therefore we get x equals 3 and x equals negative 1. Okay. Now, looking at a picture, we only saw this solution x equals 3 and not x equals negative 1. So if you remember from Math 20, we had to solve, for all these type of equations, the radical equations, we always had to kind of go and check your solutions over here. So what I'm going to do over here is like, I want to take the solution of x equals 3 and plug it into my original equation. So this is 2 times 3 plus 3 equals 3. 2 times 3 is 6 plus 3 is 9. Square root of 9 does, in fact, equal 3, so 3 equals 3. That means this solution worked. Doing the same thing for my negative 1 solution, we get 2 times negative 1 plus 3 equals negative 1. 2 times negative 1 is 2, plus 3 is 1. Square root of 1, negative 1. Well, 1 does not equal negative 1, so that means this guy over here is what we call an extraneous root. So that means we just exclude this from part of our solution over here. All right. So for this next example over here, we have x plus 3 equals the square root of 2x squared minus 7. So I'm going to do the same thing, solve this guy graphically. So we have y equals the square root of 2x squared minus 7. And the other equation we're doing is going to be x plus 3. So we have y equals x plus 3 for our y2. Okay, so we're going to graph this guy over here, and we see this guy over here. Now, just think about this graph here it looks like the graph stops here and here on my calculator, but actually this graph does go all the way over here. So this is just, I'm going to say, guys, this is a flaw of this technology that we have over here. This graph is not going to give you a very good picture of this one. It should be going all the way down to the x-axis over here, okay? But we have two intersection points. We have this one here, and we have this one off the screen here. So I'm just going to adjust my window setting a bit. I'm going to make a bigger x max, and let's go a bigger y max. I'll just go to 20 for my y max. And we can see intersection point here and here, okay? So to figure this out, we'll second calc. Intersect, enter, enter, enter. It gives this one with x equals 8 is one solution. Second calc, intersect. Enter, 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 and we have x equals -2. Okay, so guys, I'm not going to actually sketch this. We saw what the picture looked like earlier on. So we know that this is x equals 8 and x equals -2. Okay, figure out this one algebraically. So we have x plus 3 equals square root of 2x squared minus 7. That's going to do this work here. X plus 3 equals square root of 2x squared minus 7. If I square both sides, we get x squared plus 6x plus 9. That's what happens when you square x plus 3 squared, equals 2x squared minus 7. So we get 0 equals, and so if we bring these three terms to this side, x squared minus 6x, -7 minus 9 is -16. There we go. So factoring this, we get 0 equals x minus 8 times x plus 2. Therefore, our solutions are x equals 8 or x equals -2. Now, for our check, which we need to do for these questions over here, let's check 8. So we have 8 plus 3 equals the square root of 2 times 8 squared minus 7. 8 plus 3 is 11. 2 times 8 squared is 128 minus 7 is 121. Square root of 121, 11 does indeed equal 11. So we know this is a solution here. X equals -2. So we get -2 plus 3 equals the square root of 2 times -2 squared minus 7. -2 plus 3 is 1. 2 times 4 is 8 minus 7 is 1. Square root of 1 equals 1. So 1 does equal 1. So that means -2 is a solution as well for this guy too. Okay. All right, just moving along, same idea over here. We have 4 equals x plus 2 times the square root of x minus 7. So we are going to use our calculator for this guy over here. Right, x plus 2 root x minus 7. All right, so here we have so far. So we have y1 equals x plus 2 times the square root of x minus 7, and then we have y2 equals 4. Graphing this function over here, we're seeing this graph, okay? Now, x plus 2 square root of x minus 7, okay? So if I go second calc intersect, enter, 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 so there's first curve, second curve is this guy over here, guess, okay? Now we're seeing no sign change, okay? So this is what you see on the calculator here, and obviously guys, when we look at this, there's clearly no intersection point between this blue line and this red line over here, okay? So there's going to be no solution for this guy over here. So that's what we're going to get graphically, that these guys are not going to intersect, okay? So we saw this picture over here. Let's see why this is the case algebraically. So what I'm going to do over here is I'm going to subtract x from both sides, and we have 4 minus x equals 2 square root of x minus 7. Same thing, let's square both sides. we're going to get 16 minus 8x plus x squared equals 2 squared is 4 times x minus 7. Fire this over to one side, we get x squared, subtract 4x from both sides, minus 12x. Add 28 to both sides, and we get a value of 44 equals 0. So I'm going to fire this in my quadratic formula here, because I don't think this is going to be factorable. So we get x equals negative b plus or minus square root of b squared minus 4ac So we get 12, negative 12 is positive 12, plus or minus square root of, we get 12 squared, minus 4 times 1 times 44, all over 2, which is 12, plus or minus square root of, so we get 12 squared is 144, 4 times 44 is 176. So 144 minus 176 is negative 32 over 2. So what this is telling us over here, we have a negative discriminant here, so therefore there are no real solutions. And we saw that in the graph that we saw earlier on. Okay, this is how this guy works well. All right, guys. So that's how solving radical equations graphically works. Hope this makes sense. And if you have any questions, please send me a message or come and talk to me in class. See you in the next video.